What's up, you guys? Welcome to Integration Bee training for intermediates. The first thing we're gonna learn is to get used to algebra manipulation. Algebra, it is, you have to be completely comfortable with algebra. You just have to, you know, factoring, conjugating, all these other things in weird ways. You have to get comfortable with it. So in this video, we're going to start practicing our algebra manipulation. So let's go ahead and get into our first integral. Here, this looks very weird, but it's actually pretty simple. This is actually a a difference of squares. So pretty much, you can factor this into square root of x minus 2, square root of x plus 2. So pretty much what we have here is that the square root of x minus 2 cancels out. So this integral is actually just from 0 to 1, square root of x plus 2. And so now, what we have is 2/3. We have here, this is just power rule, basic power rule, right? And then, I mean, plug in 0, we know it's going to be 0, so plug in 1, it's just going to be 2/3 plus 2. And that's it. This looks nasty, right? We definitely don't want to express this because, you know, that's just tedious. Well, there's a very cool algebraic trick to this. If you let u equal x minus 3, why am I letting u equal x minus 3? Well, what's going to happen is I make this become u. This will become u, right? But the other else is what? Minus 1, minus 2. This one's like plus 1, plus 2. So what I'm gonna end up is I'm gonna end up with an integral. Let's see, you put in the balance, it becomes from 0 to 1. And then you have u here. And on this side, it's like you're adding 1, you're adding 2. So this is just u plus 2, u plus 1 here. And on the other side, it's u minus 1, u minus 2 here. Right? Okay, but how does that help? Well, this actually helps because we know this and this, right? We know that this actually expresses into, let's see, I'll put u plus 1 here. I'm sorry, not u plus 1. Put the u in the front. U plus 1 times u minus 1, that's u squared minus 1. U plus 2 times u minus 2, that's u squared minus 4. Oh, what does this look like? This is just, we can just do a u substitution. In this case, I'll let u squared minus 1, just for easiness sake, right? Okay, so now I'm going to take this away. Alright, and so now what we have, don't forget that the derivative is 2u du, so you need that half. Okay. Alright, well, let's see, plug in 0, you get negative 1. Okay. Plug in 1, you get 0. Okay. It looks ugly, but don't panic. It's okay. It's okay. So now we have w, and this is what? U squared. We have u squared, but we need u squared minus 1 plus something to make it minus 4. Oh, well, this is just minus 3. So this is w minus 3 dw. This is why I don't let w equal u squared, because then you would actually have to express. Here, it's just a distribution. So that's why I like to let w equal u squared minus 1. Now, this is simply just w squared minus 3w. And now this is we'll let the half go here. This is now w cubed over 3 minus 3 half w squared from -1 to 0. We know that 0 is, you know, all this is 0. Okay. But then this will equal to -1 half. And then plug in -1. Let's see, this gives us -1 third. Plug in -1, this is -3 halves. Okay, and this equals 1 over 6 plus 3/4. Something like that. And you're done. You see? So much quicker than expressing everything, you know? So again, it's a lot of algebraic manipulation, but I'm showing you tricks to help you get experience with these manipulations, so that you are aware of these algebraic tricks that we can do with integrals. Now this looks nasty, right? Looking at this, it looks nasty. You're probably freaking out, oh god, maybe I have to express x plus 1, make it into x squared plus 2x plus 1, and then, I don't know, maybe do a substitute. No. Calm down. Calm down. Okay, so what you can do is use an exponent law, where if you have an times bn, you can combine ab inside of that exponent. Okay? That's what we're going to do. And the reason why I rather do that is because we know that this, what is it called? The sum of cubes? I think that's what it's called. But this is pretty much x cubed plus 1. That's what this equals. We know the special factorization. So this equals x cubed plus 1 squared dx. Now that's a lot easier to express with. It's a lot easier to see, at least. Because now we know, oh, this is just, I don't know why I put 3, but this is 2x cubed dx. So be very careful. Be very careful. But here now it's just, this is just power rule. A very basic power rule. This would be a half x4. Yeah. And then plus x plus c. And you're all done. Very, very quick. Of course, in integration bees, you're going to see years or year numbers. You know, 2022, 2023, 2024, whatever. You're going to get used to it. So, here, this looks nasty, of course, right? What do we even do? Of course, we're obviously not going to express this in 2022 terms or whatever, but and you also can't do a u sub either, like u equals inside of this, like what's going to be our du? We don't have a du. So what do we do? So this, I like to call this the absorption or absorbed u sub, and what it is pretty much this it's very hard to see. Once I show it to you, you can't unsee it, and it's a very good thing to be aware of. Let x, see this x, you can factor it out. So what's going to happen is, I guess in better terms, you know, maybe I think it's a lot harder to see it generalized, but what's going to happen is I'm going to factor this x out. Okay, and you get x 2023 plus 1, right? But remember this is all inside of an exponent. Okay? You can take it out. You're pretty much doing the reverse of this, right? And then taking it out. Okay? You're just taking that a out, and that's what you're going to do with this x. So, with that x, this will become x to the power of 2022. And then x 2023 plus 1 2022. Whoa! Now you see what's going on. This is just a basic u substitution. That's all it is. It was just sneakily hidden. It's just a u substitution. Let u equal x 2023 plus 1. And then du is equal to 2023 x 2022. So now we have the integral 1 over 2023 of u to the power of 2022 du. That's all it is. Okay, so now this is just what? U 2023 of 2023 squared. And so now this is, the answer is x to the power of 2023 plus 1 to the power of 2023 over 2023 squared plus e. That's a lot of 2023s. But I mean, that's how integration bees are. They just like to use year numbers. It's just a tradition. You're probably wondering, what the hell is this? So, when you see something like this is what I mean when we say you should always conjugate a function. Or, I guess not necessarily conjugating, but you're pretty much just multiplying top and bottom to simplify. And let me demonstrate that. So here, just only looking at this fraction here, okay? Only looking at this fraction here. What we're gonna do is, to better simplify this, right? We do this to get rid of fractions. So in this case, what we're gonna do is we're gonna multiply top and bottom by x. The reason why I want to multiply top and bottom by x is so that this is no longer a fraction. And so now we end up getting is x plus 1. Okay, so now this, so we pretty much multiply top and bottom by x here, and now we simplified it. We simplified it in x plus 1. Okay. Alright, we're getting there. We are getting there. But what now? What do we do now? Now I want to get rid of this. I want to turn this as not a fraction. Right? I want to make that not into a fraction. To do that, I have to multiply it by its denominator. So I would do x plus 1 this time. And so now we multiply top and bottom by x plus 1. Don't forget that this is as a whole. So now we multiply top and bottom by x plus 1 to get rid of this, to convert this into not a fraction. So now we go ahead, simplify this. This gets simplified into x plus 1. This is x plus 1 plus x. Wow, that is really simplified. It is really simplified now. This is x plus 1, 2x plus 1. Awesome. Now what? What do we do now? I don't know, you tell me. What do we do now? What on earth do we do now? So, interesting. Do you remember our techniques from rational polynomials? What do we do when we end up in a case like this? So, if you remember, we want to make our numerator similar to the denominator, and we want to make our numerator an easier numerator to integrate with. You know, either a derivative to do a u sub, or a constant so that we could just use logarithms or inverse tangents. Okay, so here I need x plus 1 to 2. So I don't care what this constant is. Constants are constants, right? This is what's bothering me. Okay, so I would like this x to be 2x, right? But how do I make it to 2x? Well, I multiply. Okay, I multiply 2x. Not 2x. I multiply 2 so that I can get 2x, right? Because the bottom is 2x plus 1. So I would like to make my numerator similar to the denominator so that, you know, it cancels out. But because I multiply 2, I must divide by 2. So it's that same concept again, multiply top and bottom, you know? Okay, cool. So now this is a half, and we get 2x plus 2, 2x plus 1. Okay, now what? We can take that 1 out of that 2. So this becomes 2x plus 1 plus 1. And so that now, when we write it as fractions, this cancels out. Now that's just a 1. So now we have the a half integral of 1 plus 1 over 2x plus 1 dx. Oh, cool, now it's a simple integral. Okay, so now this is just a half of x plus ln. Ooh, careful. Careful. We almost died. This is not ln of 2x plus 1. What is it? It's not ln 2x plus 1. It's a half. It's a half of ln 2x plus 1. And the reason is because of chain rule. You have this 2x. That x is not alone. You have a coefficient multiplying this x. So because of 2x, we need to divide a half by chain rule. Okay. So now we're done. And this is our answer. Okay, be very careful with that. It's not just ln of 2x plus 1, it's a half. Because of this 2x. When you see a coefficient with that x, you have to do a reverse chain rule with it. This looks very, very weird. What on earth do we do? It's very weird. Very weird. So, it's the same concept for absorbed u sub. It's the same concept as absorbed u sub. It's a lot harder to see because it's an exponent form, and the thing is, you have to get used to seeing this. You have to get used to seeing this. Please remember that the exponent 3/2 is equal to x times the square root of x. Okay? Please keep this in mind. This will save you a lot of time. If you have the mindset of just remembering this is equal to this, putting it in terms of roots, it's easier to see what's going on. It's a lot easier to see what's going on. Okay, so now that I know, well, no wonder it's inside the square root. Okay, so what's actually going on is we have e to the x plus e to the x square root of e to the x. And so, because I said it's an absorbed u sub, we can factor this out. Okay. It's not e to the x, it's square root e to the x. Okay, you're factoring it out, right? The square root is technically a rational exponent. So, now this becomes 1 plus the square root of e to the x square rooted. Oh, okay, now I see what's going on. So we let u 1 plus e x over 2. Then du is equal to e to the x over 2 half, right? Don't forget, chain rule. And then, oh, well, that's what we have here. That's what that is. Okay, so now this becomes, don't forget about that half, so it's 2 integral square root of u du. And so now we have 4/3 of u. What is our u? 1 plus square root of e to the x, and then 3/2 plus c, and that is your answer. This looks very odd. You're probably thinking, oh, trig substitution. Okay, let's do some trig substitution. Or we can split it up into doing trig substitution and stuff. No, calm down. Calm down. Okay. This, again, when you see this, there's a cube inside of the square root. Oh, this is, the exponent is 3/2. Okay. We're starting to see what's going on. Okay. So, you are kind of right about splitting it. Yes, we will split this. We will definitely split this. Right? 1 minus x squared 3/2. Okay? This is just the basic u substitution. Perfect. Very good. Okay. But here we have 1 minus x squared. Remember what I said? To think of this as this. It's a very good thing to keep in mind. It's a good thing to be aware of. Because now, oh, here's what we have. Oh, this cancels out and it's just inverse sign. There is no trig substitution. I mean, it's not necessary. It's not necessary to use trig substitution. Now we can just go ahead and dive right in. Okay, well, this is now equal to inverse sign. And then plus, and then we could do a u substitution, let u equal 1 minus x squared. So now this is technically negative, because du is equal to negative 2x. So now this is a half, and then du u 3/2 at the bottom. Well, I guess we can say, to make it easier, negative 3/2 du. And then we do power rule. Okay, this is just, let's see, plus 1. That makes it negative half. Yeah, negative half. Alright, so it's negative half. Oh, that cancels out. Okay, so now this is u negative a half. And then, I think it cancels it out. Yeah, because you divide a half. And it divides this negative half. Okay, so now we get this. This is all it is. Alright, well then now it's just, this whole answer is inverse sign plus, is it really? Oh, wow. That is such a clean answer. Well, there you go. That's our answer. See, there was no trig sub involved. You didn't need to use any of that. So, cool. What do we do with exponents like this? So, again, we have to get used to this. You can actually, because this is just a bunch of x's, you can conjoin them just to make it a lot easier to see. So we have negative 1 here, x. When there's a negative exponent, this is it divides. Okay, so now we're seeing what's going on. 2/5 divided by 3, it doesn't really simplify. That's as much as it can simplify. So, okay. So now that this is just this integral here, then it's you know, if you remember the integral for this, it's just a to the x divided by ln of a plus c. So that's pretty much what this is. So this is just 2/5 divided by 3x, and then ln of 2/5 over 3 plus c. You can simplify it if you want, but this is technically good enough. It's still a correct answer. So this is a very common one. You've probably seen it in MIT Integration B, but this comes up a lot, and you must be aware of this. You must be aware of this trick. It is it's one of those things where I don't remember my 10 derivatives you must memorize, but if you know the derivative of x 3/2, it's 3/2 square root of x. Okay, so we're gonna start using that. But how do we use it here? It's actually very, very tricky. Like I said, you always, keep this in mind. because it's very helpful to mentally see what's going on. Okay, so this is a square root of x, and it's a square root of 1 minus x cubed, but what do we do with the x cubed? It's very hard to see, but it's actually 3 halves being squared. That's what's going on. It's a 3 halves being squared. And so now you let u equal x to the power 3 halves, and your du is 3 halves square root of x. And so now this is 2/3 of the integral square root of 1 minus u squared. So it's just inverse sine. That's all this is. It's just inverse sine. Okay, and then u is x 3 halves. I'm sorry, this is not 3 halves. I don't know why I put 3 halves. This is 2/3. Be very careful. Be very careful not to go too fast. This looks very weird. X to the power of negative 2/3. And it's not a simple power rule because there's a +1 there. So what do we do? What do we do with this? We definitely can't conjugate it because that, I mean, it's x. But what the hell do we do with this? Well, when you see something negative like this, I mean, we know that a negative exponent is a reciprocal. So maybe let's try seeing it in that sort of way, right? We have 1 plus x 2/3, and then this goes into being x 2/3 plus 1 x 2/3. Okay. And of course, I mean, square roots like this, you can separate it. X 2/3 plus 1, and then this here we can, you know, yeah, square root. But let's try putting it in exponent form. Well, this is squared. This is squared, and it's inside of a square root. So then that means that this simplifies to 1/3. Okay. But does that help? Well, let's experiment with our derivative, because this looks a little suspicious. Let's see. If we let u equal x 2/3, or I guess, yeah, you're just experimenting. We don't know this for sure. But it looks like when we derive this, will it become negative 1/3? Let's test it out. Okay. Du is equal to, let's see, 2/3 here, and we do get negative 1/3 when you subtract 1 to this. Okay, and this is technically x to the power of negative 1/3, right? Because it's in a reciprocal form. Okay, so yes, this does work. This is a u substitution. However, let me go ahead and plug in +1. Now it's a lot easier. This is just 3 halves of our integral square root of u. And so now, okay, we go ahead and integrate this. This is 3 halves, 2/3. Oh wow, the 2/3 cancels this out. That is nice. So now it's 3 halves. So it's just u to the power of 3 halves. Okay, so then this is x 2/3 plus 1, 3 halves, plus c, and you're good to go. Alright. A little sneaky, but experimentation really helps. If it looks a little suspicious and you want to try something out, do it quickly. Huh. This looks terrible. Right, we have it looks messy. This looks complete chaos. What are we even looking at? So here, maybe we can test something out. We can test something out here. If we, let's see, what would it look like if we factor out x cubed, right? Then this will be 2x plus 1. Okay. And we have x plus 1 cube here. Oh! I see what's going on. This 2x plus 1, right? If our du is 2x plus 1, what's the integral of 2x plus 1? X squared plus x, and then whatever constant plus c, right? So maybe this is a u substitution. So, but we do need u equals x squared plus x. Where do we get this? Where do we get x squared plus x? From this. From that. We can absorb the exponents. We can absorb them into the exponents. Just cube 2x plus 1. So now this is just the integral of u cubed du. So now the answer is 1/4 of x squared plus x to the power of 4 plus c. Right? Again, I didn't know what was going on. I was just testing things. Experimenting things, and then it works out very nicely. Right? So experimentation, super helpful. Very, very helpful. This looks very intimidating. Well, let's kind of experiment again. We have a square root of x out of complete nowhere, right? Why do we have square root of x? That's just it's so random. Okay, well, maybe let's try factoring out that square root of x. Okay, I factor this out. We get x plus 1, but then if I factor this out, right, then we get 2 square root of x. Okay. Oh, wait a minute. 2x plus 1. Huh, this looks like square root of x plus 1 squared. Aha. I see what's going on here. Square root of x plus 1 squared. Aha. So now this is just a basic u substitution. Let u equal square root of x plus 1, then du is dx 2 square root of x. So now this is just the integral. Plug in 1, we get 2. Plug in 9, that's 4. And so now we have du of u square. Okay, this is a simple integral. We know this. It's just negative 1 over u from 2 to 4. And so now we have negative 1/4 minus negative half, so that's plus half. Okay. A half minus 1/4 is equal to 1/4 times 2, that's 1/2. So this whole integral is equal to 1/2. So I'm going to stop it right here. There's a lot more integrals that I'll show you. So I'll split this in 2 sections, part 1, part 2, for algebraic manipulation. I think this video is kind of long enough, so I hope this helps. A very good start for algebra manipulation. So thank you guys so much for watching. I'll see you guys in the next video.